Hello class, today I will be teaching about the supercooling of water. Who can tell me what supercooling is? Ooh, I can, Professor, go on. Supercooling is the process in which temperature of a liquid is lowered below its freezing point without solidification or crystallization. Very good, Jesse. Water is a liquid at room temperature because the particles have high enough average kinetic energy to flow past and tumble around each other. When the temperature is lowered, the average kinetic energy decreases. At 0 degrees Celsius, the kinetic energy of the particles is so low that they no longer freely move around, and instead are more or less locked into place, although they still vibrate. These molecules form a crystalline array and become a solid. However, it is very difficult for the initial ice crystals to form by themselves. Instead, the first ice crystals will form on tiny impurities in the water, which are called nucleation sites. Carbonated water demonstrates this concept. Bubbles do not form by themselves, but instead form on the sides of the glass or on your finger. In the absence of impurities, water will not freeze even if cooled well below 0 degrees Celsius, and thus is supercooled. In fact, perfectly pure water will not freeze until cooled to -42 degrees Celsius. Adding an impurity to supercooled water provides the nucleation site needed for crystallization to begin. Supercooled water rapidly crystallizes after the initial ice crystals have formed. We will now watch an instructional video on how to supercool water. Have you ever wanted to supercool water? Of course you have. Here's what you need to do so. 1 small cup. 1 bottle of purified water. I will use Fiji water. 1 small bowl. Table salt. And some ice. First, pour the pure water into the small cup. Next, place the cup into the bowl. Put ice in the bowl around the cup until the ice reaches the level of the water. Pour salt over the ice, making sure that no salt goes into the purified water. Wait about 20 minutes for the temperature to go below 0 degrees Celsius. The temperature of the melted ice in the bowl will be less than 0 degrees Celsius because of a colligative property known as freezing point depression. This property says that in water, for every increase of 1 in molality, the freezing point drops by 1.86 degrees Celsius. Thus, the temperature of the water in the cup will be less than 0 degrees Celsius. We now have supercooled water. As you can see, it is still in the liquid state. However, after adding a piece of ice, the water rapidly turns into ice. Heat packs are an application of supercooling. In these packs, there is a supercooled liquid, usually sodium acetate, that has a normal freezing point of 130 degrees Celsius. There is a disc that acts like a trigger. It causes the supercooled sodium acetate to freeze once pressed. Since freezing is an exothermic process, heat is released. Class is dismissed.